In last class, I have explained the concept of subnetting and gave some examples for the assignment. So subnetting is not an easy concept to understand it by the first time. So I want to explain it again with assignment examples. So in last class, I have given 3 examples for the subnetting to work on. So let's discuss one by one. So the first one is 10003/8. So /8 we can represent in another format as well. 10003/255.0.0.0. So these two things representing the same subnet mask. So all you need to do is to identify the subnet mask in different formats. So basically this is representing the value of how many bits you need to log. This is also representing the same thing. Okay, so 255 is you need to convert it into binary, so it will be like 8 ones. So basically it stating that this value 255, 8 bits you need to log. This is also directly we can, from the number 8 we can tell how many bits you need to log. So the first step is to get the starting and ending address for any given IP and subnet. So first you need to convert the IP address into binary format. So this is how we convert using this table. Then you need to log the first 8 values because the subnet mask is 8, or 255 is also representing 8 ones. Okay, so you need to block these first 8 bits. So these are logged, means any IP address in the same subnet will have same bit values, means the first octet from the left always will contain 0001010, means any IP address will contain 10 as the first octet value from the left. The remaining ones are not locked, can be anything ranging from all zeros to all ones. So that third step is to get the starting address. You need to replace remaining values, means remaining 24 bits you need to change them into all zeros to get the starting address. So it will become 10,000. How do we get the ending address? Just remaining 24 bits to ones. Okay, so the value of this will be 10,255.255. So when you give a machine this IP and subnet mask, it will do the same calculation and identify that its own IP address is 10,003, and in the same subnet it will have addresses ranging from 10,000 to all the way to 10,255.255. Okay, so this is how computer identifies that how many other IP addresses in the same subnet. Okay, so this is an example for class A private network. We have discussed the IP address classification in previous classes. So class A private IP address, if someone asks, you can either tell it starts from 10,000 and it will end with 10,000 to 10,255.255.255, or you can say 10,000/8. So this is also basically mentioning the same thing. Also you can tell, instead of /8 you can also tell 10,000/255.0.0.0. So this will represent the class A private IP address range. Let's look at another example. So here we took 192.168.1.1/16. So other way to represent the same thing is, instead of 16 you can write 255.0.0, because if you take 16 bits means the first bit will have 8 bits all ones, and the second octet also will have 8 bits as all ones, so you will get 255 and 255. So first step, we converted this IP address into binary. Second step, we need to log the values based on the given subnet mask. So in this case 16 means you need to log the first 16 bits. So these 16 bits are logged. So how many bits remain? 16 bits unlocked. Okay. So to get the starting address, you will keep the same first bit values as the same because they are locked, but the remaining ones you change it everything to zeros. So what you will get, 192.168.0.0. So this will be the starting address in that subnet. How do you get the ending address? You replace the remaining 16 bits unlocked to ones. So what you will get, 255. So 192.168.1.1 falls in this range. Okay. So this is example for class C private space. Okay. So basically you can represent class C private IP address space like this as well. Okay. Let's look at the remaining example. So this is 172.16.0.1/12, means 12 bits values are locked. Okay, so we converted the IP address into binary. Then we can lock 12 bits. The first octet 8 bits are locked, and in the second octet only 4 bits are locked. So 8 plus 4, 12. So these bits are locked. So the remaining, these 4 and these 8 and these 8 plus 8, total 20 bits are unlocked. So these can be all zeros or all ones. So in the third step, what we will do, we will keep the same values here, and the remaining one we change it to all zeros. So if you convert into what will happen, 172, this value remains same, so 16, because if you convert this binary into decimal, 16 and 0.0. Now to get the ending address, you replace the remaining 20 with ones. So what will be the value? The first one did not change, so it is 172. But the second octet, we replaced these 4 with ones. So what will be the value if you combine all these? So 1, 2, 3, 4, 5. We need to include until this part here. So this will become 8, 4, 12 plus 2, 14 plus 1, 15. 15 plus 16, 31. So the value of this binary into decimal is 31. And this is 255 and 255. So basically 172.16.0.1/12 starts from 172.16.0.0 and ends at 172.31.255.255. So this is the next address after this one. Basically this is class B private space. So if someone asks what is class B private space, you can just mention 172.16.0.0/12. So in the last class assignment, basically I have represented class A, B, C private IP address space using the subnet mask instead of telling the whole range. Okay. So I have given some more examples to work on. So work on these things. and you can verify the answers online. So there are some tools available online to do the subnet calculation. So this is just one of the URL. You can go to this site and put your IP address and subnet mask. It will provide you what is the starting range, what is the ending range, and how many IP addresses in that particular subnet. Okay. Try to work on different examples on your own and verify them on online so that you will get comfortable with subnet mask. Okay. Yeah, that's all for this class.